Hi friends, welcome to follow up. Let's have a look at problem 253, meeting rooms 2. In this video, we are going to explain a solution based on thought and the use of min heap. So here the principle is that we use data structure to solve problems. So the problem statement is actually very short. So given an array of meeting time intervals, it's called intervals. So each interval contains a start and an end. So we want to return the minimum number of conference rooms required. So here are two examples. In the first example, the output is 2, and in the second one, the output is 1. So let's have a brief look at the second one. So now you have 2, 4, and 7, and 10. So these two intervals, or the two meetings, actually do not overlap, so we can use just one room, right? So here the constraints are the following. First, the length of this interval can be as long as 10 to the power 4, and the start and end. Start is strictly less than end, and the start is non-negative, and the end is bounded above by 10 to the power 6. So with that said, basically we are ready to do the analysis. So this problem actually is very practical and intuitive, right? So first, we need to assign the rooms for meetings come first. So in this regard, we need to do a sort according to the start time. For example, in exercise 1, so these intervals or these meetings are already in sorted order. And then we can try to do the assignment procedure. So here, actually, we need to distinguish two situations. So if there are some rooms already with meetings, right? So we need to check if a new meeting comes, if there's room is already vacant, right? So this actually is the place where heap come into play. So we want to find the earliest end time. So let me walk you through the two examples. So here we have this intervals in sorted order, right? So we can first assign the meeting for the 0 and 30. So this start and 0 and ending and 30. So we put this in here in the heap. So we use the end time. In other words, store end time in the heap. Then we look at the another upcoming meetings. So let's look at the meeting 5 and 10. So this meeting will start at hour 5, say. But the available room will end earliest at 30, so which is larger than 5. Therefore, all the rooms are with meetings in progress, so we need a new room. In this regard, we put 10 into the heap, so the heap state will be 10, 30, which represents that there are two rooms, and the two rooms hold meetings. And then we look at the third meeting, so this is the 15 and 20. So now let's look at the room which ends earliest. That is the room ending at 10, right? Because 10 is less than 15, right? So when this new meeting 1520 comes, so we can assign it to the room originally holding meeting 10, right? So this way we are going to pop the end time 10 and then push the 20. This is the end time into the heap. So now the heap state is 20, 30. So after we finish the linear scan of the intervals, the length of the heap will be the room required. In the first exercise or example, the output is 2. So now let's look at the second example. So after sort, we get 2, 4, 7, 10, right? So originally we assigned the room for meeting 2, 4. So the end time is 4. Then when we look at a new meeting, 7 and 10, because the heap at the top is 4, right? 4 is less than 7. In other words, the meeting room is already available when the new meeting comes. So we are going to assign the meeting to the same room. So now what we want to do is pop 4 and push 10 into the heap. Now we have a heap that is 10. So in this regard, so the output will be 1 because the length of the heap after we do the linear scan is 1, right? So that actually covers the main idea. So now let's look at code. So the code is actually rather straightforward. So we are going to translate the above logic into coding format. So for convenience, I changed the intervals to be capital letter I. So here, let me first get the length of this meetings. So then we are going to do a sort. So here we don't need to specify keys because this will be sorted in ascending order according to the start time. So once this preparation is done, so let's first push the I naught, the end time, into the heap, right? And then what we want to do, first I want to heapify this heap. And then we are going to do linear scan. So we are going to start for I in range. So we are going to start from 1 ending before n, right? So then what we are going to have is the current start and the end, that is I at index I. So what we want to do is to check if there are room available, right? If heap 0 is less than s, it means that corresponding to the top element or this room is available. So if this is the case, what we want to do, heap q, we want to heap pop from heap, pop the smallest element. In other words, the room earliest available. And then we're going to heap q, heap push the current ending time to the heap. So this is 1. So notice that we push pop 1 and push 1. This does not increase the length of the heap or does not increase the count of the room. Otherwise, so what we want to do, we're going to heap q, heap push, because in this case the no room has ended, so we need to assign a new room. So we want to do this, and later after this linear scan, so we do the return for the length of the heap. So this is the one way to write the code. Actually, you can also specify a result variable counting the elements in the heap. That's also possible. So for simplicity, we do this. And before we make further comments, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. So this one, let's see. Here, I guess we need to make sure less than or equal. We got that there's no, it's still available, right? So here, this one is finished. Then we have 13 and 15. We can immediately assign this one. So this notice to this less than or equal to. Let's check again. Yeah, it passes all the test cases. Right. So with that said, I guess that's about it for this specific problem. So there are some similar problems like the interval merge type. It's actually good to check out and try those problems. With that said, I guess that's about it for this video. Thank you.